Hello grade 11s, we're going to be starting trigonometry, working from slides 1 to 11 from the PowerPoint trigonometry. So this is just going to be a refresher from last year when you started trig. So the first slide is saying trigonometric ratios in a right angle triangle. Now we can only use these trig ratios in a right angle triangle, in other words 90 degrees. So given given angle, theta, alpha, whatever it is, in this case it's theta, we have an adjacent side, the side next to the angle, we have an opposite side, and then we have the hypotenuse. Now the hypotenuse is always the easier one to choose. It's always opposite the 90 degrees. That will help you decide which one is the adjacent, because it'll be the non-hypotenuse side that is next to the angle, the given angle. So having a look at that, we can now define what our trig functions are going to be in terms of this adjacent, opposite, and hypotenuse. So sine will be opposite over your hypotenuse. This side over this side. So in other words, BC over AC. Cos is defined to be the adjacent side over the hypotenuse side. This side over this side. So for our triangle here, it would be AB over AC. For tan, it's going to be defined as the opposite side over the adjacent side. So this would be the opposite over the adjacent. So for our triangle here, it would be BC over AB. Now, how do you remember what sine, cos, and tan is in terms of this adjacent, opposite, and hypotenuse? There's a little silly rhyme that you can remember, and it goes, silly old hens cackle and hackle till old age. So you can see that sine will be opposite over hypotenuse. Cos will be adjacent over hypotenuse, and tan will be opposite over adjacent. So it's just an easy way to remember what these things are. Okay, moving on to the next thing, which is angles in the Cartesian plane. So this looks a little bit chaotic, but it's not too bad. With positive angles, you know that we start with 0 degrees here, it goes to 90, 180, 270, and then back to 360. We have quadrant 1 over here, quadrant 2 over here, quadrant 3, and then quadrant 4. Now, positive angles are always measured from this x-axis in an anti-clockwise direction, in that direction. If we look at negative angles, again, we have quadrant 1, 2, 3, and 4, okay? But now with negative angles, our 0 degrees now here, and we go minus 90, minus 180, minus 270, minus 360. And negative angles are measured in a clockwise direction, in this direction. Okay, so if we have a look at now an example, the example is now saying, determine in which quadrants the following angles lie. So 134 you can see is a positive angle. So it is definitely going to lie in this quadrant because 134 lies between 90 and 180. So this angle here is going to lie somewhere over here in the second quadrant, where this is 134 degrees. If we look at this negative 64 now, negative 64 is between 0 and minus 90. So it must lie in this quadrant over here, which is quadrant 4. So we measure it like this, where this is negative 64. If we look at 321, 321 is a positive angle, so we're going to use this one. And 321 lies between 270 and 360. So we know we're in this fourth quadrant over here. So I can draw it like this. And remember, we always measure from this x-axis around like that. So that angle there is 321 degrees. If we look at this one here, negative 143. Negative 143 is a negative angle, so we're going to be using this one here. And it lies between minus 90 and minus 180. So we are lying in quadrant 3. So we can draw this one like this. Now remember, grade 11s, we are not dealing with a positive one, a positive angle. So I'm not going in this direction. We're dealing with a negative one. So I'm going in this direction like this. And that angle there is minus 143 degrees. Minus 331, it's a negative angle, so I'm going to be using this. Negative 331 is between minus 270 and 360. So we're in this quadrant 1 over here. So I just draw my arm. Again, grade 11s, I'm not going to go in this direction because we are not dealing with a positive angle. We're dealing with a negative. So we have to start here, go right around, and then to our arm. That angle there is negative 331 degrees. 215 degrees is a positive angle, so we're going to be using this. And 215 is between 180 and 270, so we are in the third quadrant. So I can draw that like this. And because we're dealing with a positive angle, I know it's going in this direction like this. So this is 215 degrees. Okay, moving on to the next slide. We are now going on to trigonometric ratios for any angle theta. Okay, so if we draw any angle, okay, this here would be our radius, our r. Okay, because if we sweep it right around, we would make a circle. So we have some kind of a fixed length that we are going to sweep around here and make a circle. Now we'll have a coordinate for whatever our arm, where our arm terminates, and it'll have an XY coordinate. So all I've done here, this here is our arm, and I've dropped down a perpendicular line to the x-axis, okay? Where this value here, or that length there, will be the y value for our point, and this length here will be our x value for our point. So you can see now that I've drawn a right angle triangle with an x value, a y value, and an r value. Okay, and what we can do now is we can build up our trig ratios in terms of x, y, and r. Now y will be y over r, cos will be x over r, and tan will be y over x. Now, how would you remember that? There's a silly little saying here. Shelter your rear, because x-rays tan your exterior. So, sine is y over r, cos is x over r, tan is y over x. Moving on to the next slide. And our next slide is saying the cast diagram. Now, how we draw up the cast diagram, it's always like this. Draw a set of axes, and it is C-A-S-T, cast, C-A-S-T. Now, what does this mean to us? Well, the A stands for all. So all our trig functions, sine, cos, and tan, are all positive in quadrant 1. In this quadrant, S stands for sine, so only sine is positive in quadrant 2. In other words, cos would be negative here, and tan would be negative here. If we look in this quadrant here, only tan is positive here, and this is quadrant 3. So sine is negative, and cos is negative in this quadrant 3. If we look in this quadrant, cos is positive in this quadrant, and this is quadrant 4. So sine would be negative, and tan would be negative. And what we're going to do is we're going to use this to help us answer questions like these. So the next slide, example 2, it's saying to us, determine whether each of the following function values are positive or negative without the use of a calculator. So cos 46, now if we go back to our original where we defined our quadrants, we can see that 46 lies in this quadrant here between 0 and 90. So we are in quadrant 1 for that. So quadrant 1 is over here, and I've just drawn up our class diagram here. So because 46 is in this quadrant 1, we know that all trig functions are positive here. Therefore, whatever this is, we know that it would be positive. If we look at tan 251, so if we go back to our Cartesian plane here, 251 lies between 180 and 270. So we are in quadrant 3, which is over here. Now we know that in quadrant 3, T stands for tan, so we know that this would be positive. Moving on to the next one, sine 310. So 310 lies between 270 and 360. So that is in the fourth quadrant over here. Now we can see that cos is the only trig function that is positive in this quadrant, and we are dealing with sine. Therefore, whatever this value is, we know that it is going to be negative. Moving on to the next one, cos 123. Now 123 lies between 90 and 180, so we're in quadrant 2. Now in quadrant 2, sine is positive, and we're dealing with cos. Therefore, cos is negative in that quadrant, so this value, whatever it is, would be negative. Moving on to the next one, tan negative 350. Now what we have to do is we need to use this over here. Negative 350 lies between minus 270 and minus 360. So we are in quadrant 1. If we have a look at quadrant 1, all trig functions are positive there. So whatever this is would be a positive value. If we look at the last one, minus sine minus 143. Minus 143 lies in quadrant 3. It lies between minus 90 and 180, so we're in quadrant 3. Now we know that only tan is positive in that quadrant, and they're asking for sine. So whatever this value is, we know that it's going to be negative. Moving on to the last example. Okay, the question is asking, in which quadrant does theta lie? Now what they've given us here is 2 bits of information. So if I draw up my cast diagram, which is already here for us, and I mark this one with a tick, it's saying where is tan less than 0? In other words, where is sine negative? So we know that sine is positive here and here, so it must be negative in this quadrant and this quadrant. And I've just marked that with a tick. Now this one I'm going to mark with an X. So here they're saying cos theta must be greater than 0, so cos must be positive. So we know that cos will be positive in this quadrant because they're all positive there, and it'll be positive in this quadrant here because cos is positive there. Therefore, I know whatever this angle is must lie in this quadrant here where they both agree. So our angle theta will be somewhere in this fourth quadrant. And that will be our angle theta. Moving on to the next one. They're saying, where is tan greater than 0? In other words, where is tan positive? I'm going to mark it with a tick. Well, in the first quadrant, they're all positive here. So that's what we're looking for. Mark it with a tick. Only sine is positive here. That's not what we want. Tan is positive here. So I'll mark it with a tick. And only cos is positive there. We're not interested in that. Now this one here, I'll mark with an X. Now they're saying theta must lie between 180 and 360. Well, here's 180, 270, 360. So it must satisfy those two quadrants there. They both agree here, that and that both agree there. So I know that my angle must lie somewhere in this quadrant over here. And this will be our angle theta. Moving on to the last one. I'm going to mark this one with a tick. So they're saying, where is tan less than 0? In other words, where is tan negative? So they're all there. Only sign is here, so tan would be negative there. Tan is positive here. Tan is negative over here, so I mark it with a tick. This one I'm going to mark with an X. Where is sine greater than 0? In other words, where is sine positive? Well, it's positive there, and, sorry, an X. It's positive there, and it's positive there. Negative in those two. So they both agree over here. So I know whatever my angle is will be something in that quadrant over there. Grade 11s, I would like you to try exercise 12.3 for me, please. Thank you.